Hello, I welcome you all to your own channel MSK Learning. Now in this video we will solve one numerical problem which is from fluid mechanics and basically from the kinematics, right? So the problem is on the screen that a 30 centimeter diameter pipe conveying water branches into two pipes of diameter 20 centimeter and 15 centimeter respectively. If the average velocity in the 30 centimeter diameter pipe is 2.5 meter per second, find the discharge in this pipe. Also determine the velocity in 15 centimeter pipe if the average velocity in 20 centimeter diameter pipe is 2 meter per second. So what we have, basically one pipe is there whose diameter is 30 centimeter, right, and through which the water is flowing, right, with a velocity of 2.5 meter per second, right, and this 30 centimeter pipe is into two branches, right, whose one diameter is 20 centimeter and another diameter is 15 centimeter, right. So we have to find out the velocity in a pipe of diameter 15 centimeter, right, and we need to find out the discharge through the pipe of 30 centimeter diameter, right, and the velocity in 20 centimeter diameter of pipe is 2 meter per second is given. So this is the problem which is from the continuity equations, right. So the continuity equation is based on the principle of conservation of momentum, conservation of energy, you can say, right. So means what, the rate of flow of will be constant, that discharge in a two section is a constant, right. So first of all, what we will do for better understanding, we will draw the schematic layout of this question, right. So here we go, that solution. So this is what you have, a one pipe is there, that is main pipeline, right, its diameter is 30 centimeters. So I'll specify the dimension also. This is the 30 centimeter, right, and the fluid is flowing in this pipe with the velocity of which is 2.5 meter per second is given in the question. So this is velocity is given 2.5 meter per second. Now this pipe is into branch, right, that is two branches is there. One is having diameter is 20 centimeter and one is having diameter is 15 centimeter. So let's say it is make a branch into this format, right. So this diameter is, let's say it is 20 and this diameter is 15, right. So it is like that, means it's bifurcate from this point, right. So this is the, we can give any name. Let's say this section, this pipe whose diameter is 30 centimeter, I am considering it as a pipe 1, right, and its diameter is given to you, which is the 20 centimeter, and another diameter of the pipe is given, which is the 15 centimeter, right. Now also the velocity for the pipe diameter is 20 centimeter is given. Let's say this is the V, right. Here the V is equal to 2 meter per sec, right, and its velocity we have to find. So as I said, that this is the main branch and this is bifurcated into two pipe. One is having diameter is 20 and one is having diameter is 15, right. So this main pipe we consider 1 and this I am taking it as a 2, right, and this I am taking it as a 3, right. So here you have it, this is, you can say this is the V1, right, and for this pipe this is the V2, right, and this is the D1 and this is the D2, that is dia, and this is your D3, right, that is diameter. Here V3 we have to find, right, we need to find out the velocity of fluid, right. So this is flow in this direction like this, is it or not? So in this we have like this and the fluid is flowing in this way. So one thing you have to observe, that how much fluid is, water is flowing to this main pipe, the same fluid is bifurcating to this and this. So if you say the discharge through this pipe is Q1, then the Q1 is equal to summation of Q2 plus Q3, right. Why? Because this amount of fluid is split it into two branches right now. So now first of all we will write down the given data. Given data you already written here, so again we can write, right. So here we have a, that given T1 is equal to 30 centimeter. Our all calculation will be in meter, so I'm taking it as a 0.3 meter, right, and v1 is equal to 2.5 meter per second. All right, so as we have a d1, so we can find out the a1 also, right? So a1 is equal to what? Pi by 4 into d1 square, which is nothing but the pi by 4 into d1 is what? 0.3 whole square. So on simplification we will get some 0.07068, right? So 0.07068 meter square, this area we got. Similarly, you have a pipe 2 velocity is given and diameter is also given. So this is d2 is equal to 20 centimeter, right, which is nothing but the 0.2 meter, right? And then a2 is equal to pi by 4 d2 square, that is pi by 4 into 0.2 whole square, which is 0.0314, right? 0.0314, right, meter square. Then we have a velocity is also given for the second pipe, that is v2 is equal to 2 meter per second, right? Now then we have a d3 is given, that is d3 is equal to 15 centimeter, which is nothing but the 0.15 meter, right? Then we can find a3, that is a3 is equal to pi by 4 into d3 whole square, which is same pi by 4 into d3 is nothing but 0.15 whole square, right? So a3 we got, that is 0.01767, right? So here you can write 0.01767 meter square. a1, a2, a3 we got. That v1, v2 is given. We have to find out the v3 and q1. So first of all, we need to find out that the discharge in the pipe 30 centimeter, right? So here we go. Let's say you can write it here, just right. So now we can find out the first that discharge q1 in a pipe 1, we can say, right? So yes, so now we have a discharge q1 in a pipe 1, right? Pipe 1 means whose diameter is 30 centimeters. So q1 is equal to what? That is area into velocity, right? So area we already calculated, which is nothing but you have a 0.07068 into velocity is 2.5 meter per second. So this discharge we got, that discharge is nothing but the 0.1767, right? 0.1767 meter cube per second. All right, so first answer we got, right? Now second we have to find out the value of v3, means velocity of pipe 3. So for that we should know the velocity of what we say that discharge we required, right? So discharge we can find that. Second we can, what we are going to find, actually we have to write that velocity of pipe 3, right? Velocity of fluid, which is fluid is flowing, right, of pipe 3, right, of pipe 3, right? That is basically you have to find out the v3 is equal to what, right? So v3 again you can use the discharge formula only, that q is equal to a3 v3. So for that we know that total discharge in a pipe q1 is equal to q2 plus q3, right? So q3 we don't know, so q3 is equal to, we can say q1 minus q2. q1 we already calculated, this is the q1, right? So then q2 we have to find. So q2 is equal to what? a2 into v2, right? So here we go again, that q2 is equal to a2 into v2. a2 you already calculated, which is a 0.0314, right? 0.0314 into velocity in the pipe 2 is also given, which is your 2, right? So this q2 is nothing but you have a 0.0628 meter cube per second, right? So we can get the q3, So q3 is equal to what? q1 minus q2, right? So q1 is what? q1 is 0.1767 minus 0.0628. We got some values, not some value, that is exact value we'll get, that is 0.1139 meter cube per second. So this is the q3 you got, right? Now from this equation we can find out the which we call it as a v3, right? So further you can say q3 is equal to what? q3 is equal to a3 into v3. So v3 directly I can write v3 is equal to q3 by a3. All right, so this is what you have a 0.1139 by a3. A3 we calculated, which is your 0.01767, right? 0.01767. So on simplification we'll get the v3, which is 6.44 meter cube, meter per second, right? So this is how we can solve the branch problems, right? So this type of problem are come in your paper, right? So please, for more videos, do like, subscribe, comment and share. Thank you.